Karthik.
We'll start. So I wasn't available for that Q&A session actually that Saturday. Like we'll do it some other time. So how did you weekend go, everyone? Hello. Okay, I hope it was fine. Okay, yesterday, how many people were there for that last multi-threading session? Can people respond in chat? Hello.
Yeah, Karthik.
Okay.
I heard your only question that how was the weekend. Then I missed your question.
No, like the previous multi-threading session, how many people were there? Okay. Okay. Okay.
I think it's only a couple of people, I guess.
Okay. Anyway, we'll just do a quick recap. So we saw two methods of doing that, right? By extending the thread class and by implementing the runnable interface. What I wanted to show is like the previous output which you already saw if you attended the class. Like we will be printing. This is the thread with that. I mean, with that loop, right? With that I value will printing for each and every thread that is executing this loop. For example, I am initializing this particular class object. This class is this one, right? Which is extending the thread class. And when I say that, when I call that start method, it will call the start method available in the thread class, which in turn calls the run method, which we have implemented here. This run method will be executed. And what happens is like initially I didn't give the value as 500, I guess gave the value as 5, right? I'll just run this program, I'll see what happens. Okay, I think maybe we'll give 3. Just wanted to show one quick example actually. Yes, okay. So if you give this as 3, now what is happening is like uh, when a thread is executed, what we have say like it is running parallelly, right? Now what is happening here is like thread 0 is there. That's the name of the thread which I printed here, right? Get name we are printing here, right? We are starting the thread, we are printing the name, and we are what the thread will do, it will run. I mean, it will execute this run method, right? Now what is happening, we are also starting this thread 2, right? Now you see this output. The thread 1 is completely executed, then this thread 2 is executed, right? And we are starting this runnable implementation second class here, and we are calling its run method. And once all is completed, this particular implementation is executed, right? So you're getting what I'm trying to say. It should happen in parallel, but it is also happening sequentially. Can anyone say why it is? It should happen parallel. Thread 0 and thread 1 should run parallelly, right? But here the output is sequential. Thread 0 is completed, thread 1 is executed after that. Then this runnable implementation second class is executed as the order that we have given here in the main function. Okay, I hope I wasn't confusing about the question. Everyone got the question what I'm trying to say, right?
Karthik, can you go to the thread class?
Okay.
Yeah,
Thread
where
class
you
is
mentioned
a
that.
inbuilt class actually.
Yeah, where you mentioned that prints, like, where you're using system print, system dot print. Okay. With my understanding, we're having two objects, right?
Yes.
For the, I think it finish the first object and comes to the second one as
Ah,
well. So
yes, but ideally it shouldn't happen because it's a multi-threading. The start method, both objects should execute simultaneously. Right? That's what multi-threading is all about, right? Okay.
yeah, true, Karthik. Yeah,
Yes, actually it is executing simultaneously, but since the loop is so small, within the start of the next thread, the entire execution got completed. That is what happening here. This is what I was trying to show. Uh, for example, like if I increase the loop to some 30, let's see what happens. Previously, the output was like all the thread is from the thread 0, right? How I'm getting this number here is like I'm just comparing here. If the run method is called, I'm just getting the thread name, what thread is calling this run method. If the name is thread 0, then I am initializing a variable integer called thread num to 0, else to 1, right? So whenever I'm printing this, then I will print to the particular thread number only. Okay. So if I increase the value to 30, now let's see what happens. Now it is a mix and match, right? Thread 0 is executed for two inputs. Now it comes to thread 1. Thread 1 is started. Now it comes as alternative. Now this is from thread 0. This is from thread 1 until all these things. Again, this is from thread 0. So it's a mix and match, right? And see, in between this runnable implementation also came because we started this run method for the second class here two times. One is by passing the S3 object to a thread class and starting its run method, otherwise calling the run implementation whatever we given directly. So now you can see this thread 1 and 0 alternatively it's coming, right? So meaning it's executing in parallel 10101011. So now this loop didn't complete uh, before the starting of the next thread. The next thread started at the point here. Now the both the threads are alternatively calling this run method in a separate thread, and it's trying to print this particular loop. So that's the whole point here. Hello. Everyone like got what is happening here? At this particular 29th thing, all the thread 1 loops got executed and remaining thread 0 loops were only there, and those were executed after this. Right? Now everyone kind of is okay like what is happening here, and or do you wanted to repeat again? Mithun has responded. What about others?
Karthik,
Yes.
can you just repeat once again?
Okay. So previously, when the loop was 3, right? What is happening here is okay. Let's take the 3. So it is very clean actually. Even now, what is happening here is like I have initialized two objects. I'm calling this run method by s1 dot start, right? what I'm doing with the start method is like it will call the start method in the thread class, and which in turn will call the run method in the overrided class here. So when you call start, the thread is in the start state initially, then it will call the run method which you overrided and given some custom implementation here. So basically you can assume the start method call this run method. So that's what happening here. We are calling this run method in two separate threads by creating two separate objects and calling the start methods individually for each object. Right? So far so clear, right? So now what happens is like both the threads we are creating through a separate thread, right? It will start to execute parallelly. So when I say s1 dot start, this particular object's thread will start executed parallelly in the core, and it will call the run method. Now if there are more than one core, each core will have a thread name in our Java implementation. So default name which every thread has is like this: thread 0 and thread 1, thread 2, like that. So what I'm just doing is like I'm just using an if else condition. If the thread name is thread 0, means if this object is trying to access the particular run method, then the thread name will be thread 0. Then and I'm initializing the variable to 0 here. Else I'm initializing the value to 1 here. Meaning if the thread name is 1, then the thread number will be initialized to 1. I'm just using the for loop to print this particular thread number, because I should know while printing what thread the current for loop is accessed and what it is executing, what iteration it is executing. I should know, right? So I'm printing the thread number and I'm executing the iteration value I here. So now what happens when I give s1 dot start, the thread will start to execute. I'm just printing the thread name here, and I also start the second thread through line number 35, and I'm just printing the second thread name here, right? So both the threads will start to access this particular run method here. If the thread first thread is accessing, then the thread number value will be 0. The second thread is accessing, the thread number value will be 1. So I'm just printing this particular this is a thread string in the console, along with what thread number and along with what iteration the particular loop is currently in the particular thread at the particular given time. Now both will start executing parallelly, so only we are getting this kind of output, right? So now the thread 0 has started. Even before starting of the thread 1, it has executed the two statements in thread 0, right? The start method will call this run method. Two times this for loop is executed even before this happened, right? Even this before this is dot out dot println happened, two for loop got executed. Then this line number 33 happened, so only we are printing thread 1 here. And once that has happened, this the second thread has created, and it is started to execute this for loop once in the second thread, starting from here, right? And when all this was over, the third thread was started by this runnable implementation here, and it has completed. So why this output is there is like because all the things are executing parallelly. Even if you increase this iteration value, you can see more mix and matches. Put to 10, you can see more mix and match of printing here, right? 0 0 1 0 1 0. All this is printing in a mix and match manner because both the thread are running parallelly and both the thread are executing this for loop simultaneously and printing in the console. This particular line is printed in the console by thread 0. This particular line is printed in the console by thread 1. Both are two different threads in the system, right? Right, Shiva?
Yeah, thanks, Karthik.
Okay. Even if, okay, just wait a second. Okay, we'll come to the synchronized later. Even the println method, you can see something called synchronized, right? what is synchronized is like if more than one thread is trying to access this println method, then it will wait until one particular thread execution is completed for the particular iteration. Then it will allow the second thread to access this println method. So only the println, it is always thread safe, right? We call it thread safe because if both the particular thread try to execute this println simultaneously, then it will lead to something called deadlock, right? It will throw interrupted exception, right? We saw in what is interrupted exception when we saw the thread dot sleep example. I remember, right? Interrupted exceptions, like thread is running, but if something is interrupting its operation, it will throw an interrupted exception and the whole execution stops, which we don't want. We'll see the synchronized examples later when we cover the collections thing. Maybe. There are many terms which we have to know in Java multithreading. One of the important thing is synchronized. Okay? So inside any method like this, inside the synchronized block, when we do something, then if a particular thread is accessing this method, it will wait for the method execution to be completed by the thread. Then it will allow the next thread to access this println method. So only there is no confusion in printing all the iterations of thread 0 and thread 1 here because of the synchronized. Otherwise, it might lead to some problem because we have asked it to execute up to 10 iterations, right? 0 to 9. It might have stopped in 5 or 6 because at that particular instance of time, two thread might have accessed this println method at the same time. I hope I was not confusing. So when I say synchronized, this is a synchronized block. When I pass parameters as this, that this represents the object itself, right? The thread which is executing the object itself. What we saw this keyword example in the when we created the constructor and all. We say this dot some variable is called the same variable name, right? So why we use this? This represents that particular object itself. So we pass this parameter here and we try to execute whatever is available in the particular synchronized block. So we call this as thread safe, right? This now this println method is thread safe. So fine, like Dibya, Mithun, Vinay. Okay. There are a few more concepts in multi-threading we'll cover as we see the collections framework. Uh, but the thing to realize is like multi-threading is always kind of some dangerous path. I'll show you some small example. Yesterday I was working on a small personal project actually. Can any of you say like where the multi-threading will be needed actually? What are the scenarios the multi-threading might be needed? You can unmute yourself and talk.
Does it do with parallel execution?
Okay, what are the scenarios the parallel execution might be needed?
Uh,
Okay, let's think initially in Selenium perspective itself. Why we need multi-threading in Selenium?
As I just mentioned, it's for the parallel execution.
Okay, so maybe one of the main important or only purpose in Selenium related to testing is parallel execution, right? When I say parallel execution, two browser instance or two or more browser instance should open parallelly and start to execute different tests, right? There may be some 10 integration tests we have in our system. What should ideally happen is like each node execute sequentially all the tests, because it will take a lot of time, because every time the browser has to initialize, it has to log into the system, log into the particular application, and it has to do some checks over there, filling some form or validating some page and all. But it is very costly to do everything sequentially. If you run some regression test cases, 100 cases, then it will probably take more time. But when we execute parallelly, for example, if some one test case takes 10 minutes, if there are 100 test cases, then it will take 1000 minutes. 1000 minutes is kind of what, more than 14-15 hours, right? But when we do that in, let's say we are doing it in three threads parallelly, three browser instance starts to execute, and the time is reduced by 1 by 3, right? So instead of 1000 minutes, it is going to come around 330 minutes, means 5 hours or so. So 14 hours execution is reduced to 5 hours, the main advantage. But we have to be careful in doing that thing, because we have to use those synchronized blocks wherever needed. For example, if you're reading the test data from Excel, uh, there will be something called object lock, right? If you're trying to access the same sheet or even same row from the Excel to get the data, if two threads are trying to do that same thing, then it will lead to a thread lock situation, and the data will not be read and your execution will be failed there itself. So whenever there is a resource accessing method, then you should use synchronized there, right? Maybe I'll just show small example here. Maybe we'll do it practically in the some other class. I just show. Maybe. Okay, so you use keyword called synchronized in the method level itself. You can see here, right? For example, assuming this method is going to access that particular Excel sheet and it is going to return some value. So in those cases, it is always safe to use the synchronized keyword before the return type. The return type is void here. Synchronous keyword like this, because once you use the synchronous keyword, then Java will know, okay, if a particular thread is executing, then I should not allow any other thread to access this particular method until the thread things are done with this particular method. Right? It's very useful, right, in kind of accessing the resource like Excel sheet and reading and all. So now, what in this example, what they are trying to do, they are trying to increase the particular value of count variable with the value which we pass in the parameter. Now, two threads cannot access this simultaneously. It can go one by one, because I don't want this particular count value to be increased simultaneously by two threads, which doesn't make any sense. It will lead to a deadlock, right?
Karthik, can you just share this link?
Okay, I'll just share this entire thing itself. This Genco is kind of very important, useful website actually. Uh, if you want to learn basic and even advanced Java, this website is kind of very useful. Posted to Mithun. Okay. Okay. just go through this particular Genco. He has kind of this site is run by a person called Jacob Genco. He has kind of everything what Java basic and advanced users should have. This website is very useful actually. Okay. But I would suggest to go through this website once you have basic understanding from the sites like Java T Point. Java T Point gives a very simple basic examples for us to understand. This will be in the next level, little complex, but still it's one of very good sites where you can have reference of Java. And there is one more website called Journal Dev. Have you guys heard of this website? Okay. This is very good website to learn Java. Just go through this. It has all the basic things which you will need for Java, right? You can see here in the left nav, or you can see this Java tutorial here. This is also kind of little advanced compared to Java T point or tutorials point, but it's kind of very useful website. I would also suggest you to understand the basics from Java T point and come here. Journal Dev is very important website actually.
Karthik, share the links, please.
I've shared the links, show in the chat. Can you see? Got the
Okay.
links, right? Okay. So if you have the time, have the look at this also. And if you kind of encounter any um point where it's hard to understand, then this is the place to go. Very basic, simple examples, understandable examples. It has tutorial for almost everything here, but it's kind of very basic actually. To start, it is very good. Okay. So this is the basic idea. Synchronized block. Okay, what we are trying to do here is like this is one of the personal project which I am working on. In this particular project I'll be just trying to import a video and through some application server, and I just create a folder with a random name. This is a random name generated by a thing called UUID, and I just paste that video here by doing some process. I also do something called transcoding by putting this video uh, in some API called Coconut API right here. So what happens is like this particular transcoding process takes hell lot of time. It takes 10 minutes to complete. But I should also return some results, right? It cannot, our API call cannot wait for 10 minutes, right? This is kind of a basic testing which I have done yesterday. For I'll just show a thing, delete all these things. So now this folder is empty. I'll just try to run this particular program and show to you. This is created in a framework called Spring. So now what happens if you try to run this program is like it is going to something called controller. Initially, whatever we API call which we hit here, it will come to this part called controller. And this in this particular part, we are getting this multi-part file. Multi-part file input is a binary file actually. You can give any binary file. For example, photos, videos, these are binary objects, binary files. Even CSV, Excel files are binary files. You can give those, and it will pass that file to this particular method. And what that method will do, it will take some path from our system, and it will create a directory from this UID generated if the directory is not present, and it will put that particular video in that particular directory, right? And I also have this some random job configured and try to post this particular video for some job called transcoding. We don't worry about what's transcoding, just think that transcoding is going to take a lot of time, right? I have configured this particular application to use this resource to a maximum of 30 MB, right? I have configured here. If it's more than 30 MB, a video or a photo, then it will not take. Okay? I can test this particular program through my Postman. So the particular server is running in the localhost 8080 port. The endpoint is API v1 video. Okay? How the endpoint is calculated? Because in the controller we have given API v1 video, right? Yeah, slash API slash v1 slash video. This is the endpoint. Now what I'm doing in Postman is like I'm just passing this body as a form data with only one parameter with a key file, and this value is this mp4 which we have browsed. I can just browse here, right? I can select files and browse here. Any mp4 file would do. For example, I'm taking this mp4 file. This is kind of some video, right? It's some video. I'm opening it here. What I'll do, why I'm passing this key as file is because we have configured like that only here. Value it is expecting as file only for that key, right? So now I'm posting it. Now it has immediately sent me a response, right? But we don't know what has happened in the Eclipse. We'll just go and see. Yes. Now in the console, if you can see, something has happened. This transcoding process has started, and this progress is in 0%, right? And status is in processing. It will take a lot of time, but I've already returned the output, right? If you go and see this thing, a new folder is created, and this video is put here, and transcoding process is happening in the parallelly. Okay? But can anyone say like what is the problem here? I'm returning nothing actually. If you can see in the Postman, I'm returning nothing, no values returned. But ideally, what I should return is like, if you see the return type of this particular method, I've posted this as void. But ideally, what it should return actually, this particular return type I have posted as a media transcode DTO class, right? It should be a return type. So ideally, what it should return? Can anyone say? And what is the problem with this implementation? Can anyone say? Is something related to multi-threading? What's the problem related to this implementation? What might be the problem that can occur in future? No, before that, can understand? Everyone is understanding what is happening here. So if everyone can reply, it will be very useful for me. Okay, I'm just uploading a video here through this Postman API. Forget this part. Forget what is happening in this code. I'm just uploading a video here and putting it somewhere in our. This code will what it will do. It will put that video in our file system somewhere in our path which I specified by creating a folder name which we generated in the code. and will put the video here. It will also do some process called transcoding. Transcoding is like splitting the video into many frames, 360 pixels or many resolution, 360, 720, 1080 pixels resolution is there, right? So split the video in all the resolutions. That process is called transcoding. That is done in this code. But transcoding generally it will take some 5 to 10 minutes to complete. But I'm already returning the result, which is not good. I'm just returning null, right? So only the postman response is nothing, null. But I should return something here to know, okay, something is happening here, so that the process is success or failure. At least that it should know, right? I'm not returning anything here. But what is the problem with this implementation? I should return something also, and there is one problem with this implementation also. The problem everyone got, right? What's the problem here, or what we are trying to achieve here in this particular project? Mithun, Vinay, Shiva.
Yeah, Karthik, I understood that you're trying to upload a video uh, upload the video, right? As you mentioned,
Yes, yes,
and you are using the Coconut API as you mentioned, right?
yes. Coconut API is
And
for transcoding purpose only.
yeah, uh,
See,
yeah,
video is resource intensive task, right? I'm just copying a entire video here. This is kind of 13 MB video, which whatever I posted. But what if the video is 300 MB, 400 MB? It is going to take some time to process the video and put it in the location which we said, right? So ideally, what should be the configuration here? This particular method should be synchronized method, right? What if two APIs are trying to put a video in the same server?
okay,
Then ideally, this method should be synchronized. Right?
okay,
What is the other problem here? This transcoding process will take 10 minutes time, but I'm already returning the response. It shouldn't happen, right? So what should ideally happen is like this transcoding process should not happen in this same thread at all, right? It should ideally we should create a separate thread and put this transcoding process there for each and every video request that is coming inside, right? That is the ideal implementation. Because if the transcoding process for 10 minutes the server is locked, then no other process can happen over that server for the 10 minutes. I'm ideally returning the response immediately, but if I am waiting for the result, this particular transcoding process should be happening in a separate thread. I should create a separate thread as we saw in the previous examples. I should put a run method there, and I should shift all this code to that run method only. So every time if that is happening, then a separate thread will be created. That particular transcoding process will run for 10 minutes in a separate thread, and this particular thing will not be blocked. That particular transcode media file will not be blocked for execution for that 10 minutes or so. So these are the, I mean, I hope I was clear with some points. These are the main design considerations. Even while designing the automation framework, we should always be careful with these constraints, right? It is always risky to deal with multi-threading. If you are dealing, you have to deal it properly.
okay.
Okay, what about Dibya, Vinay? Everything fine? No, I hope I'm not putting too much into it basically.
No, I think it's once we go through the concepts of multi-threading, okay, and I think whatever you just said would be add value, and we can come back with any clarification needed, I guess.
Okay, it is multi-threading will not stop here. We are going to see so many examples of multi-threading in upcoming classes also. Maybe we'll try to see 2 3 examples also. I'll see in the collections framework. Maybe if you just go through the websites also, which I've given in the link, actually, it's kind of useful. We'll try to do this in some other session also. Right? It should always be an assumption that two separate processes are running in our processors, two separate threads, two separate workers are running. And we should always be careful in 2 3 scenarios where one method should not be accessed by two threads simultaneously. One resource should not be accessed by two threads simultaneously. And what if I wanted to proceed with the next step by joining all these threads? For example, that assume that there is some operation in our Java where I should there are two threads doing two separate works. And what if my next step should execute only after this completion of these two steps? Those things are there. Right? Those kind of scenarios might also happen, right? So getting what I'm trying to say. For example, let's say you are reading an Excel itself, right? Let's assume you are reading a username from the Excel in one thread and password from the Excel in one thread. It should not happen, but just say assume. And you are logging into a particular web application, you should have username and you should have password also. Without both information, you cannot proceed to login page. What if the next step is login page only? You should, example, the username fetching thread is completed its process. But if you proceed to the login step without this password step, then obviously it doesn't make any sense, right? So getting my point, everyone. So there are many cases where we should wait for the particular thread to complete operations, then we should proceed, actually. So everyone getting my point here? Everyone getting my point here?
Yeah, sir.
So what I was trying to show here is like, wait, let me put this to at least 30. Okay. Now there is something called join method in the particular thread class. It's very useful method for the whatever scenarios I have told you. For example, in this particular case, this without this join method, this runnable interface implementation was coming in the between. Can you remember in the previous? Maybe I'll remove this join and show. Uh, I'll remove this join. I'll just execute this same program here. Okay, can you see this runnable interface implementation here? It's coming in between because the third thread and fourth thread has also started. While the first thread and second thread has already started to run. Why this kind of output is there? Can you imagine? Can you assume like why this runnable interface implementation coming in between this thread 0 and thread 1? Because this s3.run and t.run is also executing, four threads are executing parallelly. So this particular runnable interface implementation is also got because we are overriding this run method and we are printing this here runnable interface implementation. So this thread is also running parallel. What if I wanted to run this particular thing only after completion of this s1 and s2 threads? Then I can simply use this particular join method so that the remaining steps are always executed once after completing these two threads, right? So if you try to run the same program again, then always it will be in the last only, irrespective of how many iterations you give. here. No, I hope this is not too much of a overkill currently. Once you have a better picture of what is multi-threading and how it is running parallel, I think it should be easy. You're understanding, right, what is happening here? Hello?
Yeah, Karthik, it's clear.
Okay. What about others? Dibya, Mithun, Vinay? I hope you people didn't log in and just went out of the chat or Zoom. Hello, Mithun, Vinay, hello.
Yes, Karthik, it's clear, no issue.
Okay, okay. Maybe we'll remove this. So now instead of 4 threads, there are only 3 threads that is running. And always this, the third thread is what? This is runnable implementation, and this implementation, the run method contains some console we are printing runnable interface implementation. So whenever we try to run this particular code will be always executed last because we have used this join method. It is always executed last. Without this join, it can execute anytime. If we comment this out, it can be executed at any point. I think you see it's executed here in between. So that's the basic idea. And nowadays in Java 8, there are many implementations where you don't have to, starting from Java 8, where you don't have to worry about some process that you have to do parallelly. There is something called Java streams, which is kind of very. We'll cover this streams in later, but I just want to show you. There's something called Java streams, which was introduced in Java 8. It's kind of very useful in processing data and all. But if you wanted to process some data over some iterations, 1,000, 10,000 iterations, then it will take hell lot of time, right? But main advantage of this Java stream is like it has inbuilt methods which can handle task parallelly. Maybe I'll show some. Okay. So now yeah, they are trying to read some file here, and we have having this stream object here, stream of strings, and which we have read from the file, and we are passing those to the stream of strings. And there is something called parallel method in this string, and for each and every line, it will execute this system.out.println, right? So basically, we are just trying to print each and every line in that particular file. So the first method is kind of used without parallelism, and this is with parallelism. So always with parallelism, you can achieve the fast outputs. For example, if the particular output is coming in 20 milliseconds, maybe it will come in 10 milliseconds. So in collection framework also, if you have this list and all, you can read this, and you can print this particular line in as a list of string itself. List is a collection. We maybe we'll see in the next class. List is also a collection where we store an object of a same type. Right? So and we are printing whatever available in that particular file there. So Java streams are a implementation of this multi-threading concepts in the Java library itself. But only one disadvantage with respect to Java stream is like instead of our own implementation, it might take some more time for some particular input data actually. For example, if we give our own implementation for some sort methods, it might be more efficient than relying on Java streams. All right. I think it's too much of overkill today. Maybe I don't want to. We'll see the streams later. But understand that in Java streams also inbuilt in Java itself providing some parallel execution. Generally, before 4 or 5 years, we have to build our own framework with worrying about too many things, right? But nowadays, many wrapper libraries and wrapper tools are available, so that you don't have to worry about parallelism. But still, it's these are things which are always good to know, because when you use a particular framework like TestNG or Cucumber BDD, Serenity BDD, it itself will provide implementation for number of threads, multi-threading and all. You just have to specify number of threads somewhere, and you will start to execute the thread parallelly. Those are options which are kind of made a tester's life very very simple in with respect to automation framework creation. Okay. Okay, these are the things which I wanted to say today. So, any questions until now? We'll start with collections from tomorrow. So, anyone has any other question? Hello.
Yeah, Karthik.
Any questions, Shiva?
No, I think it's good, but as I mentioned, I'll go through the multi-threading concept, and if any doubts, I'll get back to you tomorrow in the session.
Okay. Okay. Then can we wrap up the session then?
Yes, sir.
Okay. Okay, people. We'll
Yeah, thanks, Karthik.
meet tomorrow. Thank you.